This lesson will be an introductory lesson on solution stoichiometry. And just as a reminder of what stoichiometry is, remember it's a method in which you can use dimensional analysis to be given a certain piece of information and then solve for your unknown. So the standard stoichiometry problem we've worked on is an example like this one, where you are looking for how many grams of carbon dioxide are produced when you burn 12 grams of methane. And in order to solve that, we used dimensional analysis where we took the mass of A and converted that into moles of A, then looked at the ratio using the chemical equation between mole A and mole B to then solve for the mass B. In solution stoichiometry, you're going to have a much more complex version of dimensional analysis, and in a solution stoichiometry you're given information on the solution, either given volume or the molarity, and then asked to find either the mass or volume or molarity of another solution or another chemical. So this is a classic solution stoichiometry problem. How many grams of sodium chloride must be added to 1.5 liters of 0.1 molar silver nitrate to precipitate all the silver cations? So one of the key parts to doing a solution stoichiometry is adjusting your schematic, and this is the overall schematic, which should definitely be written in your notes. So the general concept is that with every problem, we first write the chemical equation, then we balance it, we label information on the chemical equation, we refine our schematic, and then we solve. So let's go back to the problem that we originally had as a solution stoichiometry problem, where it asks how many grams of sodium chloride must be added to 1.5 liters of 0.1 molar silver nitrate to precipitate all the silver cations. This is a problem you have as your sample A problem on the electronic or hard copy handout that I have given in class. So our first step is to write the chemical equation. So we need to start off by recognizing what chemicals we actually are working with. So it's asking for how many grams of sodium chloride must be added. So because it's being added, we know that that is a reactant. And just a reminder, sodium chloride, Na, remember that has a +1 charge. Chlorine has a -1 charge. We write that as NaCl. And then it is talking about silver nitrate. Silver, just as a reminder, has a +1 charge. Nitrate has a -1 charge. So that also can combine as a 1-to-1 ratio. So our chemical equation thus far is NaCl. And if I look at my solubility chart, I see that it's aqueous, combines with silver nitrate, and thanks to my solubility chart, nitrates are also always aqueous, and I need to find the new combination of how these would rearrange themselves. So let me just draw it out for myself because it definitely makes it easier for me. So here I have my different anions and cations, and so now I'm going to have the AgCl combine and the NaNO3, and these look like they can all more or less be combined without adding any more cations or anions. So we have AgCl. When I look at my solubility chart, I see that this actually does become a solid, and I have NaNO3, and this remains aqueous. So the next step is to balance the chemical equation, and when I look at this, it looks like it's completely balanced. Next part is actually labeling what information I have. So over here it tells me that I have 1.50 liters of silver nitrate. I know that's my volume. It also tells me that I have 0.100 molar solution. That's my molarity. And for for sodium chloride, I'm asked to figure out how many grams. In other words, the mass is what I'm looking for. Okay, so now let's take a look at the schematic that we had previously looked at. Here's our schematic. All right, so we need to start by recognizing which of our chemicals is A and where to begin. So A, remember, is always the one that has all the information and none of the unknowns. So that is this one right here. Let's try that again. So here's my A, and in A I see that I have volume and molarity, and this is my B right over here, and I'm looking for mass. So let's see how we can use that schematic to work our way through this. So we're at A right over here, and it looks like we have volume and molarity, and we want to go to mass B. So the schematic we would use is we'd start with volume here, and then move to molarity. Molarity will let us move to moles. Mole A will allow us to get to mole B, and lastly we can get our answer of mass B. So this is the schematic we'll be using, so let's write that down for ourselves. So we know that we start with volume A first, then we're going to use our molarity A to get to our mole A. Then from mole A, we're going to use the equation to get to mole B, and lastly to mass B. All right, so let's put in and plug in that information. We start with 1.50 liter Ag NO3. I'm going to use my molarity. Now watch how I'm actually going to write out this molarity, and I'm writing it out this way so that it allows me to cancel units, okay? Just as a reminder, remember molarity is moles over 1 liter. So in this case, if I have a molarity of 0.1 molar solution, that's the same thing as writing 0.100 mole AgNO3 over 1 liter of AgNO3 solution. And the reason I want to do this, because remember this is the same thing as saying this here, is that it allows me to cancel out my liters and silver nitrate, which is what I'm going to do. And this automatically gets me to this point right here, because now I have my mole A as an answer. So by doing this step, I'm actually doing 2 steps in one. So the next step is getting from mole A to mole B. And I use my chemical equation to look at the ratio. And it looks like I have a 1-to-1 ratio. So that means 1 mole AgNO3. And I'll put on top 1 mole of NaCl. That allows these to cancel out. Okay, and then the last step is getting these moles of NaCl into grams, and that is easily done using the periodic table, where I know that I have 1 mole NaCl having a mass of 58.4 grams of NaCl. That allows these to cancel out, and I have the answer of 8.77 grams of NaCl. Let's try the next one. So for the next one, we see that it's an acid-base titration, and we want to neutralize it. So I'm told that I want to find the volume of 0.100 molar HCl, and I'm given 25 mils of 0.35 molar NaOH. So we start, as always, with writing the chemical equation. So we have HCl plus NaOH, and these now need to make into we need to get the products, because we recognize it's an acid and a base. We know that water is going to be one of the products, and then the other two items are NaCl. So let's see if we need to balance it. It looks like it's completely balanced already. Let's add information on this here. So as we have seen from above, we have the volume and the molarity of our NaOH, but are still looking for the volume of HCl. So we're going to look back at our schematic yet again and see what it is that we're going to, which path we're going to follow. And just as a reminder, remember this is A and this is B. Looks like we have volume and molarity, and we're looking for volume of B. So in that case, we have our volume of A. We'll use the molarity of A to get to mole A to mole B, then use the molarity of B to get to the volume of B. So let's write down that schematic. So we have volume A to molarity A to mole A, mole B to molarity B, and to volume B. So let's put in our dimensional analysis. 0.025 liters of NaOH. Again, we're going to write molarity like we did before, where we're going to write moles on top and the liter on the bottom. So we have 0.350 moles of NaOH over 1 liter of NaOH. This allows us to cancel out those units. Now we are automatically, like last time, already at mole A, so we just need to look at the ratio on the chemical equation, and it looks like it's still a 1-to-1 ratio. So 1 mole NaOH requires 1 mole of HCl. That allows those to cancel out. And now we're going to work on molarity again, and now here's the trick to this one. Molarity, we know that when we're making equations, or better said fractions like these, we can put them either way, meaning we can flip them and they still mean the same thing, okay? So writing 2 moles over 1 liter is the same thing as writing 1 liter over 2 moles. They both allow you to explain the molarity, okay? So these still show that 2 moles were used and you filled it up to 1 liter. That's what strategy I'm going to use right now for this here. So I can tell that I have 0.00 moles of HCl diluted in 1 liter of HCl solution, which allows me to cancel those out, in which case I then have the answer of 0.08575 liters of HCl.